So this section is law of cosine, or law of sines. The next one is law of cosines. So I'm just going to give you the theorem, and this is a true statement. If I take the sine of angle A divided by side A, so remember, if angle is the capital A and then the one across is the side in lowercase, it's equal to the sine of angle B across from side B. And that equals the third angle, sine of C over side C. Okay, so when we use law of sines, we can solve for an angle or we can solve for a side. But you have to use two of these, not three. We're never going to use all three, just two. So let's decide which one we need. Side B is 19, angle B is 40, angle C is 115, and we want side A. Alright, so when I figure out which ones I'm going to use, I have angle B and side B. So I'm going to use that part of the formula. And then I want side A, but do I have angle A? No, but can I get angle A? All the angles in a triangle add to 180, so I'm going to take 180 minus 40 minus 115. And that's going to give me 25. So this angle's 25, and I'm going to use that to get my side. So I'm going to use this one. So once you have the two that you're using picked out, you have to fill in three numbers. So let's do that. Sine of A, angle A, big A is 25. Side, little a is what we don't know. B, big B is 40. Little b is 19. So see how I put a number for this, and this, and this, and this is what I'm solving for. You have to have 3 of the 4 filled in order to use this. Okay, so now we're going to solve. And we can cross multiply, but I'll go through the steps. We basically want to get rid of these fractions, right? So I'm going to multiply both sides by the denominator. So I have sine of 25, the a's go away. But over here, the a goes on the numerator, so I have a times the sine of 40 over 19. And then we do that again. To get rid of this fraction, I multiply by the denominator. And over here I have 19 times the sine of 25 equals a times sine of 40. So if I go back here, sine of 25 over a equals sine of 40 over 19. So right here, the shortcut to that is what we say cross multiply. So I would take the diagonals and multiply them with an equal sign between. And that gets me back here. So if you want to avoid the 2 steps, this is just a 1 step to get to where we are. Okay, so remember our goal is to get a by itself. So I'm going to divide by sine of 40 on both sides. And now I just have a. So now let's calculate that. 19 times sine of 40, oops, 25, make sure you type it in right, divided by sine of 40. So 12.5 rounded would be side A. Let's do one more. So law of sines gives us 3 that are equivalent, but we need to use 2, which should be a B. So let's see what we have. Side A is 28, angle A is 93, angle C is 16. So I can see I have angle A with side A. That means I'm going to use this one. I have both of those numbers, I'm going to use them. Okay? And we are trying to find the missing side, B. So across from angle B is side B. So I'm hoping I can use this one because it has what I need. But do we know angle B? No, but can we get it? Yes. Okay, all these angles add to 180. So I'm going to take 180 minus 16 minus 93. Get 71. So now let's fill in what we know. Angle A is 93. Side A is 28. Angle B is 71. Side B is what I don't know. So we're not using this one at all. I have my 2. I filled in 3 numbers. I'm solving for 1. Okay, so let's cross multiply. So I have B times sine of 93 equals 28 times sine of 71. To get B by itself, I'm going to divide both sides by sine of 93. And then I'm actually just going to change these because I already have it typed in. So don't erase your history every time, because then you can just change the numbers. 26.51. Alright. So let's do one more. This one's a fill in the blank where we're solving for an angle. So I know angle B is 143, side B is 28, and side C is 24. And we want to find angle A. So if I have my law of sines written out, remember I can only use 2 at a time. So I'm definitely going to use B to B, right? Because I have angle B and I have side B. So I need angle A. But I don't have side A, and there's not a way to solve for sides. It's not a right triangle. So I have to use this one because we know side C, and if we can get angle C, we can get angle A, because all the angles add to 180. So this one's going to take a little bit, and that's okay. So sine of B, 143, divided by 28. Equals sine of angle C divided by side C, which is 24. Cross multiply, I'm going to write it right here, 24 times sine of 143 equals 28 times sine of C. So I want C by itself. So first I'm going to divide by 28. And I'm not going to simplify this out because I don't want to round until the very end. Okay, so I have this whole thing that equals sine C. And I'm not done because I just want C. I don't want sine C, just C. So the opposite of sine is sine inverse. So I'm going to take sine inverse of this whole big thing. So go to functions, sine inverse. 24 times sine of 143 divided by 28. So 31.05 is angle C. Oh, I'm rounding to the nearest tenth. So 31.1 is angle C. Now I can get angle A by subtracting from 180. So 180 minus 143 minus 34.1. 31.1. My bad. 5.9. That's a tiny angle. Remember that these are not drawn to scale. Okay, like that angle is definitely not 143. That'd be really big obtuse angle. Okay, so the last part, it's gonna ask for different possibilities. Okay, so we have different congruencies. Maybe you remember them from Math 1, maybe not, it's okay. So we have AAS, that means angle, angle, side. ASA, SSA. So the rough one is when we have SSA. So it means we have an angle with two sides. Those can make two different triangles. And this shows you how. These sides are the same, the angle's the same, but the triangles are not the same. So our angles can be different. There's a chance we'll have a different number of answers, right? So I'm going to draw this triangle. A, B, C, side A, side B, side C. So we have a 47-degree angle, a 25 side, and a 22 side. So we have a side, and an angle. SSA. This is the one that creates multiple answers when we're dealing with law of sines. Okay, so to do these, we just do it normal. We're going to do law of sines. We're going to do C and C, because that's what we have. And then we're looking for angle A, and we have side A. So these are the two we're going to use. Let's plug it in. Angle C is 47, side C is 22. Angle A is what we don't know, side A is 25. Cross multiply. 22 times sine of A equals 25 times sine of 47. I'm solving for A, so I'm going to divide both sides by 22. And then I don't want sine of A, I just want A, so I'm going to take the inverse sine of both of these to get angle A. And again, it's already in here, don't always erase your work. So that's 56.2 is angle A. And then we get the second angle by subtracting from 180. So 180 minus 56.2 is 123.8. Okay, and that's because one angle is acute and one is obtuse. And we're finding both of those possibilities, right? So there's always going to be our acute angle, that's one we usually find first, and then the obtuse by subtracting from 180. You guys, if you round at all, you're going to get the wrong answer, so do not round until the end. Okay, let's do this one. This is just saying determine how many possible triangles. So, ABC, we know 11, 8, 89, side, angle. Okay, so that means it could be any of these. Multiple options. So again, it's kind of sucks, but you have to do law of sines to see what's going on. Okay, so it's the same one where we know C is 89 and side C is 8. We don't know angle A. We know side A is 11. If I cross multiply, and it's the exact same process every time. You should get pretty quick at it, as you can see me writing really fast. The 8's cancel out. We take inverse sine of both sides. And I don't clear my calculator history because I know it's always going to look like this. look. This triangle cannot exist as it is. Okay, because of these side lengths, there's never going to be an angle that works with that. With this is 89. So when it's undefined, it's 0. Okay, if we were to get a number, an acute number, it would be 1. Or sorry, 2, like we did on our last one. So we have one more. Let's see what we got. ABC, ABC. A is 19.5, C is 22.4, 39.7. Hey, side angle! What do you know? Same setup as last time. All of these set up the same way, okay? So sine of C over side C, sine of A over side A. I'm going to cross multiply and do the exact same steps as we've been doing. Okay, so divide by the number, then take the inverse of both sides. So, sorry I'm going fast through that part. I feel like once you get the hang of it, you're gonna see what to do. So see how this one, I got a number, I got an acute number, an acute angle less than 180. That means there's 2 answers. Okay, and that's usually what happens, either an undefined or 2 answers. So, I'm trying to find it in here. Okay, so 2 possible is what we usually get. The 1 possible, 2 triangle, if you get an obtuse number first. So we didn't see an example like that, but remember obtuse is greater than 90. So if you see that, it's just, that's it. Okay?